So the next speaker is Rahul Karnik. Rahul is there online. So Rahul, welcome to the event.
Thank you.
I'll just give a brief intro to Rahul. Rahul is going to speak on voice over NR, VoNR. So I'll give a brief intro to Rahul. Rahul is a director of service readiness at Ericsson USA. He has been with Ericsson for 10 years and has worked with telecom operators in several countries, including USA, Canada, Germany, India, South Korea, and Japan. Rahul was a key member in setting up Ericsson's Voice over LTE Competence Center in the USA. Rahul is currently working on readiness initiatives related to ORAN and CBRS. Rahul has been working as a consultant in various areas related to telecom since 1995. So Rahul, it's great to have you speak at the event. So I invite you to start your talk.
Let me share my screen. Let me know when you can see my screen.
Yes, Rahul, we can see it now.
Great. Thank you, Professor Rajesh, and thank you to all the organizers for the online winter school. It is great to see so many people joining and taking advantage of all the sessions that are being conducted. This session, Voice over NR, or as some people refer to it as VoNR, is going to be an introductory session to Voice over NR, as well as how it relates to Voice over 5G. So an in-depth knowledge of 4G and 5G is not really required to understand this topic that I'm going to cover. It'll help in certain areas, but I'll try to keep it generic for everybody in this session. And the primary intent is to familiarize you with voice over NR, uh, some of the functionalities, some of the uh, requirements in order to roll out voice over NR services, as well as what is happening in terms of current deployments. In terms of the topics that I would like to talk about, I will start with some of the guiding principles required for voice services. We'll then talk about what it takes to get from where we are in terms of voice deployments over to 5G and voice over NR deployments. And finally, I'll end with some of the quality aspects of voice over LTE as well as voice over NR. Primarily, how do we define voice quality, and how is voice quality managed in these networks? So from yesterday, I attended quite a few sessions in which there were references to 5G. And most of you must have noticed that all the discussion as well as the use cases that were being referred to were in the data domain. So primarily, if you heard some of the sessions, Professor Karandikar talked about the use cases around enhanced mobile broadband, about MMTC, the massive machine type communication. He also talked about URLLC use cases. We then heard Tom Daly this morning talking about the game changer use cases, as well as some of the use cases that Sandeep just brought up within the 5G ecosystem. And a lot of focus was on data services. Nevertheless, voice has been around through various wireless generations, and it will continue to exist when we talk about 5G, and that is a topic that I'm going to focus on. Let's look back at when LTE was introduced, and that was a step when voice was being offered. Up until LTE, voice was being offered as a circuit switch service, And when LTE was introduced, it came up with an implementation of voice, which was also called voice over LTE, which was a packet switched implementation. So the primary difference between the two is that in a circuit switched implementation, the end-to-end path required is pre-established, and all the resources required for that particular session are pre-allocated. Whereas when you go to a packet switched deployment, those resources are dynamically allocated, resulting in a more efficient use of the resources. So that is when voice over LTE came in with release 8 of 3GPP, when the 4G networks were introduced. Now, when telecom service providers think of offering voice services, what is it that they need to pay attention to? And although this may be quite obvious, we'll contrast it with some of the services that are currently available. Uh, One of the things that they need to start with is to make sure that there is reliable scalability. We need to make sure that it is when we need to talk to somebody, or when somebody needs to talk to us, uh, the the service that is available is reliable, as well as it needs to scale to pretty much everybody who carries a phone. So that makes pretty much every human being on the planet, and some having more than one device, and especially now with some of the additional devices which are not traditional phones, if you will, also offering voice services, that number keeps growing. Hence, we need to make sure that a scalable service is offered to whoever needs to use it. The next principle is keeping it simple, having a reduced complexity, especially for the users. Now, to make a call, a voice call to somebody, or to receive a call, I need not necessarily have to invite the person by sending a link, or have them download an application, and so forth. So you get the point there. The service needs to be a simple service. And finally, we need to make sure that the operations that we are talking about when it comes to a voice service are seamless when it comes to various boundaries. And the boundaries could be between various telecom service providers. They could be boundaries between countries. You could be calling to a non-wireless device. You could be calling to any type of receiver there. So we need to make sure that the operation from a user perspective is pretty seamless in terms of making calls and receiving calls. Um, at this point, I would also like to point out that there are several different over-the-top voice and video services that are available, such as the one that we are using right now. We have Skype, we have WhatsApp. There are several such services that are available. But if you are interested, you might want to look it up and compare and contrast the services that are offered by telecom service providers to the OTT services, especially in some of the functional as well as technical areas. And from functional areas, I'm talking about things such as being able to reach emergency services when you really are in need of using them, to technical areas such as battery consumption, the number of data connections that get set up while setting up a voice session, and so on. So the point that we are going to be discussing in more detail is related to voice as we move into 5G. We know that there are a lot of operators, telecom service providers, who have already started deploying their 5G networks, and we need to look at what is it doing to the voice services. Let's take a look at what some of the guidance is provided for these services. At a very high level, I'm going to uh, show you the architecture. This is extremely high level for 4G networks and 5G networks. The primary domains, network domains, if you will, in a 4G network are the LTE access And then you have the core components, primarily the evolved packet core, which supports the session management, mobility management, etc. And finally, you have, for supporting voice and video services, a component called the IMS, which is the IP multimedia subsystem. And this offers functionality not just for your basic voice, but for what is called as supplementary services, such as three-way calling or call barring, call forwarding, etc. So that is essentially the primary domains that support voice communication in a 4G network. When it comes to 5G, there are equivalent components from a domain perspective, and those are, for the radio access, you have the NR or new radio. For the core, the equivalent of the evolved packet core is the 5G core, which obviously has a different architecture internally, as well as some of the functionality is upgraded to provide additional features related to 5G. The IMS component remains primarily the same, although certain features get added here to support 5G, such as specific KPIs related to 5G, as well as the interfaces between the core and the IMS. So these are the components that are required to support a communications service such as voice or video within a 5G network. And the components, as you can see, are fairly similar to the architectural components that we had within 4G. The guidance that 3GPP has provided in terms of voice services in 5G networks is that 5G should be using uh, a similar architecture to that was being used for 4G voice. And by that, what they mean is to provide a voice communication service which is based on IMS, which we just saw about the functionality. So VoLTE and voice over NR, I'm going to keep using voice over NR as opposed to VoNR, just for the sake of this session, because that is the topic that we are discussing. So VoLTE and voice over NR are essentially IMS-based communication services that use different access technologies. In 4G, the radio access technology is LTE, and the voice service is called voice over LTE or VoLTE. And in 5G, the radio access technology is NR, and the voice service is called voice over NR or VoNR. Pretty obvious. But there is one area that I would like to highlight here, which is you will also see this term being used in discussions related to voice when it comes to 5G, which is voice over 5G. And how is that when it, or what are the differences when it comes to purely the voice over NR service? And we'll take a look at that in the next couple of slides, because there are a few additional options that need to be considered while offering, when we talk about voice over 5G services. Let's take a few minutes to talk about the path of how voice over LTE was developed, because it is very relevant to the path that we are going to take when we start deploying voice over NR. And for people who are familiar with this, you may recall that LTE was deployed and started rolling out in about 2009, and VoLTE as a service started getting deployed in around 2012. So up until that time, what was the solution for voice in 4G networks? And you may have heard this term, which is circuit switched fallback, which is nothing but uh, going down to the circuit switched network to support a specific service. In this case, let's say a subscriber is in an area where they do not have LTE coverage at call setup. So when you're trying to make a call, when you're initiating a call, or when you're getting paged for accepting a call, let's say you do not have the appropriate ability to make a VoLTE call. And that could be for various reasons, like the one listed here. You might either not have coverage, or your device might not support it, or the service provider has not enabled it in that particular tracking area. There could be several reasons. But the solution to that, until VoLTE was available, was CSFB, or circuit switched fallback. Once VoLTE became available, there was still an issue for which a solution had to be found. And the issue was, and I'll make a reference to one of the sessions yesterday. We heard Indu Das talk about some of either the places where LTE is not available, or there might be coverage gaps or coverage holes, as they say. In those cases, we needed a solution to support uh, calls that are already in progress. So let's say you make a voice call, it gets connected as a VoLTE call, and given that this is a phone call, it is very likely that you might be mobile, you might be in a car, you could be in a train, and it is possible that you might be in and out of LTE coverage. To support that and not drop the call, the functionality which is called SRVCC, which stands for Single Radio Voice Call Continuity, was developed, where the call again is handed back to a circuit switch network, but it is a handover as opposed to a fallback. Slight difference in those two. We have a handover when we are initiating a call, and we have a we have a fallback when we are initiating a call, and we have a handover when the call is already in progress. Now, when it comes to 5G, uh, we have to talk about a couple more things than just uh, what we have seen with LTE. And the primary reason is because there are multiple architectures that are supported for 5G. You must have heard of standalone and non-standalone architectures, which are the deployment architectures that various telecom service providers are using. And I'll quickly refer to that because I haven't seen that being discussed in any of the previous sessions. So I'll quickly talk about them. You have essentially the two dimensions, which are standalone and non-standalone in one area, and then you have 4G and 5G cores. So this is the evolved packet core and 5G core in the on the other axis. So these are the viable options. There are a few other options, obviously, but those were not deemed viable in terms of deployments. And hence, these are the most viable options that you're going to see with most telecom service providers. And depending on which option the a telecom service provider decides to go through, there are going to be certain cases that need to be handled. And those are the ones that I'm going to talk about really quickly. And that will also help us in understanding the difference between just purely voice over NR and voice over 5G. So in the previous one, this is going back to the previous slide, any architecture that you see where the access used is NR for carrying voice, that would be referred to as a voice over NR service, in which specifically the access used is NR. Intuitively, you can tell that the other option is voice over 5G, where any component that is used to carry voice is a 5G component. So it necessarily need not be the NR access type. And in such cases, we have to cater to the same issues that we dealt with when we went from the deployment of VoLTE, where we saw circuit switched fallback and we saw SRVCC. We have very similar issues here. And the two things that we need to talk about here are what is called as the EPS fallback, which is similar to circuit switched fallback, but the fallback is to the evolved packet system. The evolved packet system is nothing but the LTE access and the evolved packet core. It is also referred to as a RAT, or a radio access technology fallback. You might hear this term being used in this context also. And what essentially is happening in that case is the UE context is being transferred from the 5G core to the EPC. And for those who have a familiarity with some of the components within 5G core and EPC, specifically the context is being transferred from the AMF, which is the access management function within the 5GC, to the MME, which is the mobility management entity within the EPC. And similar to the SRVCC, we have a handover which is called as the inter-RAT handover in this case, where the sessions are handed over. Now we are talking about a session being handed over because this is a call that is in progress going from the 5GC. Again, same transition, but to slightly different components in this case, where we are going from the session management function and the user plane function within the 5G core to the mobility management entity and the serving gateway within the evolved packet core. Moving on, we will talk about the various migration options. What are the telecom service providers doing in terms of going from their initial state, which is LTE, going over to their targeted end stage, which is 5G standalone? And in that case, somebody might decide directly to go from an option one to an option two. Very unlikely that this happens, because most of the operators decide to start with a an intermediate, which is option three, where you may also have heard a term called ENDC, where you have the EU TRAN and NR dual connectivity. So you are able to connect to both the LTE network as well as to the NR access in this case. And the migration path that the operator chooses is to go from option one to deployment option 3 to deployment option 2. In some additional cases, you might also see an operator go from option 3, where you are still using the EPC, and then the only component you change at that point or upgrade to is the packet core, uh, where you go to a 5G core, and you still have both accesses in place, which is LTE and NR, and finally you go to your standalone situation. So in the leftmost column, which is the option one, you obviously have VoLTE as your primary voice solution. In the rightmost column, you have option two, where you have voice over NR as your primary voice solution. But in the middle, that is where you need the two additional functionalities that we spoke about, which is the EPS fallback as well as the IRAT handovers. And finally, I'm going to talk a little bit about voice quality, how it is measured, how it is defined in these networks. And most of the operators, they define voice quality in three primary areas. That is in accessibility, or the ability to access the network for voice calls, to initiate voice calls, retainability, or the ability to continue voice calls up to their intended completion. And I say intended because there are a lot of times where calls get dropped, and that is one of the key retainability KPIs that the telecom service providers track. And finally, you have integrity, which includes the clarity of voice that is being used, as well as other audio impairments, uh, which you hear when you're deploying some of these services. You hear of things such as one-way audio, muting, garbling, that all gets tracked within the integrity part. There are two different levels of KPIs. I'm going a little fast here, just looking at the watch, but you have service KPIs and network KPIs. Service KPIs are service specific. So in this case, we are talking about voice services, and we will have KPIs which are specific to voice. And network KPIs are are also referred to as resource KPIs, more network level domain specific KPIs. So for voice calls, and this applies to both voice over LTE as well as voice over NR, the primary KPIs that get looked at are the call setup success rate and call setup time for accessibility, the dropped call rate for retainability, and then you have mean opinion score, speech path delay. Some people also refer to speech path delay as mouth to ear delay. And you have the media interruption time, which is also referred to as handover time in certain cases. So these are the KPIs that we need to look at from a voice quality perspective. And these in turn depend on several different network KPIs. And what you will notice here is there are KPIs from all the different domains that get included. So the point to note here is that the end-to-end network needs to be tuned and optimized in order to get an efficient voice service working. Most telecom service providers track these KPIs. Some track them at a very granular level. They do it at a cell level, at a site level, at a cluster level. But most do that at either a market level or a regional level or country level, and that determines what type of management they need to do, what type of optimization activities need to be performed on what parts of their network. It also allows them to look at how they compare with some of the other service providers, with their competition. In some countries, the regulatory bodies also need the service providers to meet certain thresholds of, let's say, dropped call rates, and there are penalties that could get associated with if those are not met. So with that, let me stop, and I would like to thank you for giving me the opportunity to talk, and I would be happy to answer any questions if we have any in the chat window.
So thanks, Rahul, for your excellent talk on voice over NR. It was a kind of departure from the usual networking talks
Yes.
that we've been having till now. So let me see. I see a few raised hands. I think I'll allow one of the attendees to talk. Rahul, I'll just try that for the first time.
Sure.
So one of the attendees, Malati, has raised her hand. I have enabled her to talk. Can you go ahead, Malati, and talk? Okay. So what I'll do is I'll try the. So I have one more attendee, Jayakrishnan Divakaran. Jayakrishnan, can you go ahead and talk? I've enabled your microphone.
Hello.
Yes, please go ahead. Yeah, you're audible.
Wonderful talk. Could you just highlight the type of codecs used in this 5G NR for voice?
Yes. So until now, with voice over LTE, we've seen several different codecs being used. But when we go to voice over NR, there is a requirement of using either the EVS codec or the H.265 codecs. Also, there is a lot of work that is being done on the IVAS codec, which is the immersive voice and audio services codec. That is still being worked on, but initially we will see most of the services being rolled out with the EVS codec as well as the H.265 codecs.
Thank you.
Sure.
Okay, thank you, Rahul. Thanks for accepting our invite and coming and giving this interesting talk.